Now we're going to talk a little bit about how we can use our calculator in parametric mode. So one thing, you want to think about hitting that mode button. Normally your calculator is in function mode, but if you arrow over, it'll say par, P-A-R, or parametric, depending on the version of your calculator, and you can hit enter. That'll put us into parametric mode. You can also hit enter to go into polar mode. We won't use sequence mode, but you've probably done a little bit of work with polar. And, notice while I'm in polar mode, if I hit y equals and I type on my variable button, what variable shows up? You get theta, because that's r in terms of theta. And if I go back and I go to my parametric mode, which we're just now learning about, in parametric mode, if I hit y equals, you'll see I have my x in terms of t and y in terms of t. We have an x sub 1 and a y sub 1, so those go together. And again, if I hit my variable button, I get t. Now, one of the equations that we worked with, or the set of parametric equations that we worked with in a previous video, was x equals t plus 3 and y equals 1 divided by the quantity t plus 3. So let's look at graphing that. When we graph that, it's not going to show up exactly like we had graphed it on our paper. And one thing we want to think about is changing our window. And there's something really important that you always need to set when you're looking at your window. So right now it's giving me a Tmin and a Tmax value. Tmin and Tmax are saying, these are the parameter restrictions. So for this problem, we stated that the Tmin was -2 and the Tmax was +2. And then the T-step can be any number. The smaller your number, the smoother your curve will be. I encourage you not to make your number too small or your curve won't show up nicely. So I'm going to hit T-step. I'll just make it 0.01, and this is going to draw it rather slowly. So now let's hit graph. And you can see that the curve is a little bit different than what we initially had graphed on the screen. I'm also going to change my window. So I'm going to change my x and y values so it looks a little bit more like what I had graphed originally. So I'll say x is from maybe -1 to +2, and that my y values are from 0 to maybe 6. And I'm just choosing those numbers arbitrarily also because I know what we had graphed. And I'm realizing I set my x's and y's wrong. I need my x to go from 0 to 6. So that was a learning moment. And my y's to go from -1 to +2. So now we see a curve that looks more similar to what we had graphed. So looking at this, I just want to let you know, what would happen if I had changed my Tmin and Tmax? Maybe I have that go from -2 to 0. So you'll notice the graph is a bit shorter. Or what if I have my T-step? What if I have it count by ones? So that means it's going to do a calculation at -2, -1, and the next integer would be 0. You can see my graph has a little angle to it. We did 1, 2, 3 calculations, one at each endpoint and then one at that corner section. So I'm going to go back to my window and I'm going to have that go from -2 to 2. I'll have it count by 0.001, which that means it's going to do between -2 and +2. That's tenths, hundredths, thousandths, 1,000 calculations between each of those. So that's 5,000. And if you look at this, you'll notice it's drawing it quite a bit slower. So really the main thing is when you're looking at these parametric equations and you're graphing them, you want to make sure you have your T parameter set up correctly and that you're viewing it in a way that makes sense. Let's look at graphing just one more from our example video. So I'm going to go back. We looked at a problem where x was equal to 5 cosine t and my y value was equal to 3 sine t. Close my parenthesis. I will delete those other pieces, and we'll look at our graph. Now, we're not zoomed in correctly, so I might go back and hit zoom 10. Oops, I think I hit zoom out. I'll hit enter to stop it. I'll go zoom. Standard is 6. So we see that ellipse. Now, we also want that to be in a square mode potentially. So you might want to hit zoom 5. That gives us a more accurate depiction of the ellipse. So the last thing I want to talk about again is that t. You'll notice, and we are in radian mode here, but you'll notice this goes from 0 to 2 pi. What happens if I have that go from just 0 to 1 pi, so 3.14? I go back to my graph. How much of my ellipse is drawn? You'll notice only half of the ellipse because we start at 0 and we end at pi. All right, so just thinking about that t value, that's going to be very important for you. As always, if you have any questions, please send me an email and let me know. I hope that helps, and let me know if you need extra help with using the graphing calculator.